How's it going, Apes? Welcome to another lecture here. We've already kind of looked into the major pollutants, metallic pollutants that we find in water, the lead, the mercury, and the arsenic. And now we're going to look at how water gets polluted through acid deposition and then also synthetic compounds. And before we get going on the acid, just synthetic means man-made. And I'll reiterate that as we move on. So again, we're going to look at it, we're going to look at what happens when the acid deposition from, in this case, acid rain, or even acid mine drainage from mines. We're going to look into, and then we're going to again look at how man-made organic compounds affect aquatic organisms and humans as well. So about 40 years ago, people started to notice in the US, Northern Europe, China, and Russia that forests, soils, lakes, streams are starting to become more and more acidic. And as a result, you can see the picture on the left, trees began to, forests began to die, the water acidity was unable to sustain fish. And so what became clear of all this lower pH of water was that there was these very tall smokestacks of industrial plants that were burning coal, releasing this sulfur dioxide and eventually nitrogen dioxide. And as a result, these chemicals in the atmosphere were converted into sulfuric acid, nitric acid, and it harms ecosystems. So acid can be deposited either as rain or snow and even as gas particles. We can see here dry deposition of gas particles that were once in the atmosphere, maybe blown through wind currents, land in another location. So again, like we mentioned, the main is burning of coal. So that combustion of coal releases these acidic gases. As a result, you have this sulfur dioxide, nitrogen dioxide, or oxides into the atmosphere, and then again, as we mentioned, comes down in rain or as particulates blown from the wind. And again, as we mentioned, coal burning is the major factor. So what happens though in the atmosphere is that SO2 turns into sulfuric acid, and that NO2 turns into nitric acid, and that's what makes it so toxic to the environment. And as we mentioned again, those will return either through rain or gas particles landing in a different place. So what are the impacts? What happens when we see lower pH in bodies of water? Remember, water will dissolve a lot of acids, so we have this lowering of pH, and once it gets below 5, it becomes lethal. So you see, in this case, in this picture, the acidity of this pond is way below 5, not allowing it to harbor life. So how are we combating this? Before we move on, there is no such thing as clean coal. So you may have heard clean coal burning plants and things like that. There's no such thing, because at the end of the day, we can use things like coal scrubbers, but we're still emitting toxins into the atmosphere. So what started to happen is coal scrubbers, what they do is they pass the hot gases produced during combustion through this limestone slurry. So we have this slurry of limestone. And what that does is it kind of catches some of the noxious gases. So as a result, there's less nitric oxide or sulfuric dioxide emitted into the atmosphere. So here you can see the two examples of the kind of coal scrubbers. They're down in here catching everything before it's emitted off into the atmosphere. So we can also get acid pollution in our groundwater. And unfortunately, the main reason for this is abandoned underground mines. So they get filled with groundwater. The mines have already been used. They've taken out what they've needed, and they're left behind, but so are all their chemicals. So these fill with groundwater, and there's usually pyrite or other metals in the soil that are now exposed and that will leach out. And then that lower pH even makes more metals soluble in water. And then we have this groundwater eventually reaches natural springs or waterways. And the big problem is like we said, that some of these mine companies are no longer in business, which means they're often not held accountable for this environmental damage. So the mine in Colorado, which we looked at earlier, there's no one essentially owning that anymore. So local governments and the states have to bear the cost of dealing with the problem from these mines. So one possible approach is to pass stream water through a limestone treatment facility that raises the pH of the water and removes the toxic metals to levels tolerable before it goes into the stream and affects the organisms. Okay, so there's how we can get increased acidity into our waterways. And now we're going to look at synthetic. Remember, as I mentioned at the beginning of the lecture, that synthetic means human produced. So there are these things we're producing, and there's different ways in industry. Essentially, anything that is being created in industry is a point source that ends up in our waterways. We'll look at the examples here in a little bit. And then your non-point, again, we've talked about those at the beginning chapter. We don't know where they're coming from. We have an idea, but there's so many contributing to the environment that we cannot directly point out the one person or one activity that's causing this pollution. So we see this in pesticides, pharmaceuticals, the military, and industry, as we mentioned. We're going to look at each one right now. So in regards to pesticides, so we all know they're important. Pesticides, there's different types. You can have an herbicide that will kill weeds. You can have fungicides that will kill fungus, and even insecticides will kill insects. So they are proven to work, but the unfortunate thing is that a number of concerns is that there's unintended effects. So what that means is they kill a wide variety of related organisms. You know, if the goal is to kill this certain weed in this crop, it's going to kill all the vegetation as well. And a perfect example of a synthetic pesticide is DDT. So DDT, its intended function was to kill mosquitoes or any other pests. And the unintended consequence, though, is that it doesn't just kill that pest. And a perfect case study is that while DDT, it's designed to alter the nerve transmission in insects, the chemical can move up an aquatic food chain. And we saw this as a result of the American bald eagle. It wasn't until they realized that it was through that biomagnification that the eagles were consuming these fish. And as a result, that DDT was accumulated in the tissue of the eagles. And as a result, their eggs, when they would lay eggs, they were really soft and not allowing for the new birds, the new eagles to hatch. So it wasn't until 1972 when the U.S. banned spraying the DDT, and it was all due to Rachel Carson. She did research. She saw the pesticides that were being put on the land. She saw the effects on the biodiversity. And again, it wasn't until this outcry that people started to make change. So a good book if you ever get a chance to read about someone just making a difference. And thankfully, it saved a lot of lives in the process. So moving on to inert ingredients. Inert ingredients are additives to pesticides that make it more effective. And the interesting thing about inert, it suggests that the chemicals are harmless, but that's not necessarily true. And what they usually do is this inert ingredients will allow it to dissolve in water, may allow it to penetrate into a species. So for example, some vegetation has waxy leaves that don't allow this pesticide or herbicide to kill it. An inert ingredient will allow it to penetrate through that wax and kill the vegetation. A problem is, though, is inert ingredients are legally classified as trade secrets. So, for example, companies can patent their inert ingredients, which means they can't tell you exactly what it is because, again, it's a trade secret. But that opens it up. It's not required to be tested for safety. So there are certain things like Roundup is very effective at killing plants, but it's very toxic to amphibians. And what we're starting to see is the Roundup that's not killing the plants is ending up in our waterways. And we're seeing this domino effect where because of the plant killing chemical, but because of the inert ingredients. And what's happening is it's penetrating the gills of tadpoles. These gills burst and the tadpoles suffocate. And then again, it's into other waterways as well. And the effects can be detrimental for many living organisms in those environments. Moving on in with our synthetic, there's also pharmaceuticals. And you can see here, there was a study by the United States Geological Service. They tested 139 streams, and they noticed a few things. That 50% of those streams contained antibiotics, 80% were non-prescription drugs, and 90% were steroids. The good thing is that these concentrations were so low that they aren't posing a risk to the environment or human health right now. But however, hormones can operate at very low concentrations, and inside the tissues of organisms, we have a really poor understanding of their effects so far. So right now, a perfect example that's happening is there's low concentrations of pharmaceuticals in our waterways that mimic estrogen. And what's happening is we're noticing male fish are growing eggs, reproductive or female reproductive byproducts in their testes. So it's messing with again, you don't need a lot of hormones concentration to affect an animal. And if this is affecting fish, what environmental scientists are starting to do is now they're really increasing their attention to these things in the environment. So we'll see as time goes on and as research goes on what these long-term effects may or may not be. Military compounds as well. And the main thing with military compounds is they have perchlorates, and perchlorates are found mainly in rocket fuel. So you'll see these, and NASA as well has a high abundance of perchlorates just because they need them to fuel their jets as well. But the problem is this will leach in the groundwater very easily, and humans exposed to this either by consuming water or eating food. It can affect the thyroid gland, and this affects the hormones in the body, reducing the production of hormones. So negative effects with that as well. And lastly, we're going to finish off with industrial compounds. So these are just chemicals used in manufacturing. Unfortunately, these used to be common for manufacturers in the U.S. to dispose of industrial compounds directly into bodies of water. And we saw the result of this with the Cuyahoga River, which is outside of Cleveland, which flows into the Lake Erie. But for more than 100 years, the industries along the river would just dump their industrial waste. And what this did is it formed this slick pollution on the surface. And before the fire even started, it virtually killed all animal life in the area. So the problem got so bad that by 1969, the river ignited. The river was on fire. And this led to a movement. So it led to a movement to clean up America's waterways. And now today, the Cuyahoga River is and a lot of other rivers in the U.S. are much cleaner because of legislation that substantially reduced the amount of industrial and other waste that can just be dumped into a river. So there you can see the fire in 1969. And again, unfortunately, it's bad events happen which allow us eventually to act. Another thing that industrials are putting into the waterways are PCBs, and these were once used. They're not used in the U.S. anymore to manufacture plastics or insulate electrical transformers, and they have caused many environmental problems. If you ingest any of these PCBs, they're very lethal. They're carcinogenic, which means they are cancer-causing. And the good thing is in 1979, these were no longer allowed to be used in the United States. So unfortunately, this is the United States and other countries, they can still be used. Lastly, the other industrial compounds we're seeing now that we really need to research are called polybrominated diphenyl ethers. That's just a fancy word. These are flame retardant synthetic chemical components that we add to construction materials, furniture, carpet, electrical components, even some clothing. So the problem is, though, is that since the 1990s, scientists have been starting to detect PBDEs in some unexpected places. This includes fish, aquatic birds, and even human breast milk. And what we're starting to learn now is that exposure to some of these can lead to brain damage, especially in children. So this has led to the European Union and even several states like Washington and Oregon have started to ban manufacturing of several types of these PBDEs. So that wraps up our water pollution unit on acidic deposition and synthetic compounds. Check the website, and always, if you need anything, come see me. See ya.